Welcome back, Algebra 1 students. We're in lesson 53, and we're going to talk about the power rule of exponents. So first, let's review the rules that we already know for exponents. We know that x equals x to the 1. And we know that this 1 is called an exponent. And we know that this exponent represents the number of times that the variable or the base is multiplied times itself. So if I were to say x times x times x, that would equal x to the 3 because x is used 3 times. And inversely, when I say x to the 3, it tells me that I need to multiply whatever the value of x is 3 times. Okay? So we understand that about the exponents already. We also understand that when an exponent is negative, that it means it needs to be put into a fraction form like this. And if we have something that is already in fraction form, that we need to flip it and put it into whole number form like this. All right, so we understand that already. Those are the things that we know about exponents. The other thing that we know about exponents is that whenever we have an exponent with a 0, or an exponent that is a 0, that it doesn't matter what the value of the base is or what it might be, that it equals 1. So even if I had a number here, if I had 247 to the 0 power, the answer would be 1. So it doesn't matter at all what that is. But what does matter is if I have a negative x to the 0 or a negative 247 to the 0, my answer would be negative 1. Both times. Why? Because the 0 isn't connected directly to this negative. Negative is asking for the opposite of this number, whatever this number is. All right? So the opposite of a 1 is a negative 1. Now, if the negative is included with the variable and the 0 is on the outside, then it does matter. Then you could say negative times negative is a positive, and then you have a positive 1. Right? Same thing for here. If we had negative 247 to the 0 power, that would equal 1. So it matters when you have a negative sign. If you have parentheses and the 0's on the outside, it equals a positive 1. All right. If you have a negative and there is no parenthesis on and you have the 0, it's a negative 1. Right. You should remember all of this should be in your notes. If it's not in your notes, now is when you need to put it there. All of these examples so that you can remember how they work together and what they mean. All right. I'll give you just a minute. All right, I'm going to scooch over. Let me see if I can scooch around here. Oh, it's not going to let me. I must be using the whole page. All right, so here's what I'm going to do. I'm going to clear the page. If you have not taken this down in your notes already, do so now by pausing the video now. All right, I'm clearing the screen. And go ahead and write it in your notebook. Hold on, let me answer this phone call. Sorry about that, I had a phone call. Had to take care of that. All right, so we went over the exponents, the 0 exponent, the negative exponents. So now we need to talk about combining exponents. So the other thing we need to know about combining an exponent, if I have an exponent, like so I have x to the 2, x to the 4, x to the negative 2, x to the 3. I can combine all of that by adding the exponents together. You take whatever sign the exponent has and you just combine it. So this would equal x2, this is a positive 4, negative 2, positive 3, right? You just do that math problem. So that'd be 6 minus 2 would be 4, plus 3 would be 7. So this would equal x to the 7. All right, that's all you have to do for exponents. So this is all a review for us, I'm sure. The next thing that we need to learn about exponents is power of the exponent. And what that means is if I have an exponent in a parenthesis, right? And then I have another exponent on the outside, what that means is to multiply the exponent times the exponent that's inside. So that would equal 2 times 3 would be x to the 6. All right, this means multiplication. And the reason it means that is because if I were to take x squared and do it 3 times, right, that'd be x squared times x squared times x squared. That's the same thing as this right here, right? We're just adding the same number 3 times. So 3 times 2 is 6. Is the same thing as this up here where we added 2 and 4, negative 2 and 3, and we got 7. It's just that this is all the same number. It's just multiplication, just regular multiplication. And that still equals x to the 6. This means this, which equals this. So write this down in your notes. This is the next part of exponents. This is called the power rule for exponents. When you have a power raised to another power, and an exponent is called a power, when you have a power raised to another power, we multiply. Right? Power raised to another power. Or you could also say when you have an exponent raised by another exponent. We multiply. All right? This is your sample. So let's do a couple example problems and knock this out. Let's look at example All right, here we go. Oh goodness, do they have an example for us? They do not have an example for us. Let me see if I can find an example for us. All right, here's one. X squared, y to the negative 3, z to the negative 1, raised to the second power. All right, so what we're going to do is we're going to say this exponent times this exponent for each individual variable. So 2 times 2, that would be x to the 4. 2 times negative 3 would be y to the negative 6. And 2 times negative 1 would be z to the negative 2. Easy peasy. What if we have a whole number in there? What happens then? If we have a whole number, let's say we have 2x to the 2, y to the 3, z to, let's just say it's to the 1. And we have raised that to the power of 3, or it has an exponent of 3 on that. We put that exponent on each individual factor. All right, each one of these is a factor. So this becomes 2 cubed. We say 2 times 3, that becomes x to the 6. y3 becomes y to the 9, because 3 times 3 is 9. And z, remember we have the invisible 1. Z to the 1 becomes z to the 3, because 1 times 3 is 3. Now when we have a whole number in here, and we've applied our exponent to it, we have to go ahead and solve that. So 2 times 2 times 2 is 8. So the final answer is 8x6, y9, z3. If you leave it like this, it is not correct. You're telling me halfway there, all right? So that would be the right answer for something like that. All right, what if you have a fraction? What do we have a fraction? What do we do? The same thing. So here is an example for us. We have a fraction here. We have 3, that's supposed to be parenthesis. It's just my bad handwriting. 3x to the negative 2, y to the 5 over z to the 4. All right? That's supposed to be a parenthesis. And this is all raised to the negative 2 power. You just do the same thing you've been doing. The exponent, the negative stays with it. So we say 3 to the negative 2. Negative 2 times negative 2 is a positive 4. So that becomes x to the 4. Y to the 5 becomes y to the negative 10. All over z to the 4 becomes z to the negative 8. Do we see that? Now we have to solve the whole number. So first thing we need to do is we need to put it in the right spot. So it's going to have to go down here to be a positive exponent. So now that it's a positive exponent down here, 3 squared is 3 times 3. That's 9. So it's 9 down here. So our correct answer is x to the 4. And if we want, we can swap these to get rid of the negative exponent. Z to the 8, 9, y to the 10. All right, see how much you've learned so far? Y'all are so smart. You can do this. It's all about multiplication of those exponents. All right, so let's look at conversions of volume. All right, fun stuff. Fun stuff. Let me clear the page. We are going to start using volume in our conversions, and there's a shortcut that I want to tell you. We're going to use 3-unit multipliers to convert. This is 53.1. 180 cubic feet, that's feet cubed, to inches cubed. All right, so we know we need to have that reference. We have 1 foot is equal to 12 inches. It's our reference. I'm going to show you a trick. And it is the same thing we have been doing, just in short form. So we take this and we write 180 feet. And instead of writing feet 3 times, we're going to write feet cubed over 1. Now, we're going to apply that to our conversion fraction. And we're going to convert this 12 cubed inches cubed. They have to match. And then we can say 1 cubed foot cubed, right? Each part, the number and the unit of measure, all has to be cubed. Then you can cancel this. And then you can get your answer. So then you have 180 times 12 cubed in inches cubed. Is that the same thing though? Let's see. So if we did it the other way, we would have 180 feet over 1, right? Times 12 inches over 1 foot times 12 inches over 1 foot times 12 inches over 1 foot. All right, this one is canceled by this one. This one is canceled by this one. This one is canceled by this one. We get 180 times 12 times 12 times 12 in inches 1, 2, 3 times. 1 times 1 times 1 times 1 is 1. Same answer we got up here. We just did it faster. So if you cannot wrap your head around this, do it the old way. Just know that when we have 3 as our exponent, when it's cubed, we write feet 3 times. Either way gives you the same exact answer. All right? Let's do 53.2. All right, so we're going to use 6 unit multipliers to convert 800 cubic centimeters to cubic feet. So centimeters cubed to feet cubed. This is where doing it the fast way comes in handy. I'm going to do it the old way first, and then I'll show you the new way. All right, so we need to have our unit conversion. So 1 inch is 2.54 centimeters, right? And 12 inches is 1 foot. All right, there's our reference. So the old way first, we would bring down 800 and we would say 800 centimeters 3 times. Centimeter, 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 all over 1. And we would start the process. First, we need to convert centimeters to inches. So that'd be 2.54 centimeters times all right, cancel, cancel, cancel. Now we go from inches to feet. So we want inches on the bottom. So 1 foot, 12 inches. 1 foot, 12 inches. 1 foot, 12 inches. And that's it. That's as far as we need to go. So inches are canceled. Inches are canceled. Inches are canceled. Look at how much room that took up, though. 800 times 1 times 1 times 1 times 1 times 1 times 1 is still 800. And then we have 2.54 times 2.54 times 2.54 times 12 times 12 times 12 feet cubed, because we have 1, 2, 3 feet. All right, same result, right? But we're going to do it faster. Just watch my smoke, because this is going to be so much faster. So 800 centimeters cubed over 1 times 1 inch cubed 2.54 cm cubed. Make sure everything is cubed, right? This cancels this. Now we need to go to feet. So we want feet in the top. 1 cubed foot cubed over 12 cubed inches cubed. Cancel, cancel. 800 times 1 times 1 times 1 times 1 times 1 times 1 is still 800. But now you have 2.54 cubed times 12 cubed in feet cubed. Wasn't that faster? That was faster. Not only was it faster, it took up less space. You don't have to. Now, I just stretched it out because right down here because I knew I had room to do so. But, you know, it's less room. There's only 1, 2, 3, 4 fractions instead of 1, 2, 3, 4, 5, 6, 7, 8 fractions. Half the space. So do it the way that you feel comfortable, the way that you know you're going to get the right answer. But this is an option. This gives you the right answer if you remember to cube every part of the fraction. All right, let's move on. We have one more. 53.3. We're going to use 3 unit multipliers. Actually, we're going to use 6 unit multipliers. We're going to do this one. We're not going to do the other one. We're going to convert 28 cubic meters to cubic inches. All right, so our reference is that we have 100 centimeters in 1 meter, and 1 inch is 2.54 centimeters. All right, so let's do this. I'm going to do it the fast way, okay? 28 meters cubed over 1 times, let's get rid of the meters, so 100 cubed centimeters cubed. 1 cubed meter cubed times 1 cubed inch cubed, 2.54 cubed centimeters cubed. All right, meters cubed cancels, centimeters cubed cancels. Our answer is 28 times 100 cubed. 1 times 1 times 1 is 1. We don't have to have that. Over 2.54 cubed inches cubed. Isn't that what we were going for? Haha. That was much faster than the other way. So if you can do it this way, that's great. This is the answer to this problem. All right, that's all I have for lesson 53. I will see you in lesson 54.